All right, let's do 3.1.1 right now. We're going to be using the multiplicative identity, and multiplicative means multiplying. Identity will basically tell us that we're multiplying by 1. Okay, so we are going to use something called the giant 1 today to find equivalent fractions or ratios. We're going to actually start in ratios that we're familiar with, and then we're going to transition to fractions, which we're probably also familiar with, but our work has been mostly in ratios so far. Okay, so just as a quick review, why don't you pause the video and try to do these generic rectangles to multiply these two. And when you're ready, come on back. All right, there in blue I have the answers there. 7 times 13. 7 times 10 is 70, and 7 times 3 is 21. 70 plus 21 is 91. Right? And then 4 times 235 is 4 with 230 and 5, and we get 800. 4 times 30 is 120, and 4 times 5 is 20. 800 plus 120 plus 20 is 940. All right, there's a quick review. So we're going to do a double number line to find 4 equivalent ratios to 3/5. I'm going to skip this one, and I'm just going to jump up to using the double number line to find 4 equivalent ratios to 9/8. 9 to 8. So what we're going to do is what we can do with our double number line is we can put that 9 here over 8. I don't know what that is. Maybe that's 9 boys to 8 girls, or 9 Snickers to 8 Reese's. I don't know, but something, right? Some sort of ratio. And so just as a reminder for the double number line, we can just simply increase in the top part by 9, so 0, 9, 18, while in the denominator we would increase by what? 8, so 0, 8, 16, right? And I can just finish that. On top I'd have 0, 9, 18, 27, 36, 45, and 54, right? In the bottom I could have 0, 8, 16, then I have what? 24, 32, 40, and 48, right? And what I'm doing is looking for 4 equivalent ratios. Be sure to answer the question. Don't just complete the double number line like sometimes we would do in our homework. And here's 4 equivalent ratios, right? There is 1, 2, 3, 4, 5 of them actually there. And so I could write anything like 18 over 16. I could write 27 over 24, 36 to 32, 54 to 48. Doesn't matter. I could do that 45 over 40, right? All of those are options. I could even do 90 over 80. Not even on my double number line, but I could use that to help me, right? All right. Now, let's use that double number line we just created to find the missing part of the equivalent ratio. Oh, 9 over 8 is equal to something over 40. So we're looking for, right, that 40, right? And that 40 is right there, right? So what number would we need? We'd need that 45 that goes in on top, right? Okay, that's not going to work very good. Let's go with the 45 right here, right? There we go. Right, there's that double or part that comes from up above, right? All right, let's jump down here. Find the number that makes these ratios equivalent, just like we did in the previous problem, right? But we want this 1 over 4 to equal something over 200. Well, this kind of becomes somewhat of a messy problem, because if I do 1 over 4, and then I do 2 over 8, and then I do 3 over 12, sorry, boy, I'm not going to get to 200 very fast, am I? It's going to be quite a long process, right? Quite a long process. So we have to remember that, let me fill in a couple more. 4 and 16 and 5 and 20, right? To get from the 1 to 5, we multiplied by 5, don't we? But I have to multiply by 5 to get to here, right? It's the same thing in order to be an equivalent ratio. So I'm going to do the same thing here. What does it take to get to 200, right? What does it take to get to 200? And that's going to get me the same thing over here, right? All right, let's talk about that with this, the giant 1. Well, I could jump up. Let's actually find the answer, I suppose. 4 times what? 4 times what gets me to 200, and that's the 50, right? And then 4 times, or 1 times, then it has to be also by 50 to get to what? 50. There we go. So our answer is 50. Now, there are other ways for us to get there. Just as a quick side note, I could multiply by 10 and multiply by 10. Use that 5 over 20 to get to 50 over 200, right? Those are all options, or that's another option too. All right, so let's come back here. Let's do what we just did up above, but we're going to do this with what we call the giant 1. And you see that big 1 in the middle, right there. And that 1, I would encourage you to kind of write that on in your notebook, at least for the first couple lessons, to remind you of the fact that that is a giant 1 and we're multiplying by 1. Let's just keep in mind that 4 times 1 is 4, and 100 times 1 is 100, and 1.2 times 1 is 1.2. Anything times 1 is itself. So I know this seems weird, right? But 1/4 times 1 should equal 1/4. But this 1 is a giant 1 that's going to look a little different to make my, in this case, fraction or ratio a little different. So it's all equal, but they just appear different. So to go back to our thinking that we used up above, right? What I'm saying is 4 times what number equals 200. 4 times what number equals 200. Now, we already know from up above that that is 50, right? We know that that's 50. 4 times 50 is 200. So to make this a giant 1, right, a fraction that is, to keep it as a value 1, this fraction has to be also 50. Must be. There's no other number that it could be in order for me to allow this to still be 1. So then I'm looking at my numerator, right? I'll even hide the denominator. 1 times 50 is 50. Right? So just as a reminder of multiplying our fractions, right? Excuse me, 4 times 50 is 200. Right? So I'm just focusing the denominator, and in this case, I have 1 times 50 equals 50, right? That's how we figure that out. So to keep our focus on everything that we're really trying to do here, right? We are actually saying that 1/4 and 50 over 200 is the same ratio, or equivalent fractions, or equivalent fractions too. And that's really the focus. Whether I looked at that 1/4 as an equivalent ratio, as a ratio, it's going to work just like we would with fractions, and we're going to move in the direction of fractions, okay? Move in the direction of fractions. So go ahead and let's do a little practice here. I encourage you to pause and then come back to this video. All right, hopefully you had a chance to try this yourself. We're looking at this and saying 4 times what number equals 44, right? What number equals, what number is that? I'm sorry, I'm trying to change this here. Here we go. 4 times 11, right? 4 times 11 is 44. So that means that in order for this to be a giant 1, right, it has to be a 1. This has to be 11 then. So 3 times 11 is 33. Okay. Now, just as a reminder, I know that I talked about it, and I think we should know this, but 3 over 4 times 11 over 11, just a reminder that we're multiplying the numerators. That's 3 times 11 over multiplying the denominators of 4 times 11. 3 times 11 is 33, and 4 times 11 is 44. Okay, that's my reminder, I guess, of how we multiply fractions. Okay. All right, why don't you take a second and pause the video and try these. All right, on the one on the left, we're looking at this and saying 12 times what number equals 60? Right, and the answer for that is 5. In order to be a giant 1, this must also be 5, right? So if I'm keeping my fraction multiplication in mind, right? I'm going to just put this down here just as a reminder that this is 7 times 5 in the numerator, and then 12 times 5 in the denominator. 12 times 5 is the 60. I sure hope it's the 60, and the 7 times 5 is 35, right? So there it is. 7 times 5 is 35. If we look at the right one, I hope you picked up on the fact that the equal sign is on the other side, right? I wouldn't say, I'm not saying 18 times something equals 3. No, that's not what I'm saying. I'm saying 3 times what number equals 18. Right? 3 times what number is 18? And that number would be 6. Right? 3 times 6 is 18. This must be 6. So now I actually have to work a little differently in this problem. I am now saying 6 times what number equals 72. 6 times what number equals 72. Right? Now that gets a little trickier. It takes a little extra practice, right? But the answer is 12, right? 12 times 6 is 72. So keep in mind that you got to make sure that you're paying attention as to where that equal sign is, okay? All right, so here's a little bit of a challenge. Pause this one and see, keep in mind, watch where your equal sign is, watch where your times is. If you pause this video and your giant 1 is 5 over 5, I want you to take a second, look back at it, and see, is it really 5 over 5? All right, let's take a look at this one now. All right, so what am I seeing here? I'm seeing that, in this case, because the equal sign's on the right, I'm saying 50 times what number equals 10. Ooh. So some of you may have seen this and said 10 times what number is 50, and you put that 5 in there, right? But that would be incorrect. Instead, you might have said, some of you may even put in like, what? Divide by 5. Well, that's not right either. And the reason that's not right is because that's a times sign. We're not going to just slip in a division. Now, could you get the right answer by hitting that divide by 5? Yeah, I guess you could. But that's not what the focus is, and that would kind of hurt what your goal would be, the direction that we're trying to move here, okay? So whenever we multiply by something and you want to have this division, like in that case a divide by 5, you actually multiply by 1/5. 1/5. Now let me take a second just to show that denominator, right? So this is 50 times 1/5, and it should equal 10, right? But let me rewrite this as, we always write this as 50 over 1, right? That's an equivalent fraction right there, times 1 over 5. Now remember what I said before, we multiply the numerator, so this is 50 times 1 over 1 times 5. 50 times 1 is 50, and 1 times 5, that looks like 56, but 1 times 5 is 5, and 50 divided by 5 is 10. That's our goal. See how that fraction fits in there? Okay. This still must be a giant 1. Don't be fooled by this process, so this must be 1/5. Let's do that workout here on the side, right? 35 times 1/5, right, is 35 over 1 times 1/5 to equal, I'm running out of room, so I'm going to have to go to my right now, 35 over 5, and 35 over 5 is 7. Okay, tricky little problem, a little bit of a challenge there. Okay, just to kind of sum things up, right, what are things that we need to look for? If we are looking at the green part, be sure that that is 1. Whatever is in the denominator or in the numerator must be the same number. They have to be the same number, okay? Be sure you know in the purple part, make sure you know where the equal sign is, right? To make sure that you are finding the correct number in there. And then in the blue part, remember that this is multiplication, not division, right? So the blue came up in this problem, right? It has to be multiplication and division, right? The purple part came up in the problem here on the right because the problem switched, so make sure you're keeping an eye on that. And then the last part of just making sure that it's 1. That's really important, okay? If you have any other questions, please let me know. Have a great day.